නිතරම හිතන දෙයක් තමයි මේ ගණිතය විද්‍යාව දර්ශනවාදය මේ සංකල්පයන්ගේ පැතිර යාම අතිශය වැදගත් අපිට රටක් විදියට ඉස්සරහට.
From the quiet streets of Wattala, a lifelong journey of curiosity began. Nurtured at Nalanda College, Colombo, and later at the University of Moratuwa, his journey was driven by a pursuit to understand, discover, and transform knowledge into impact. This path led him to over a decade of pioneering research at SLIIT. He wasn't just a scientist. He was an innovator, turning complex ideas into patented technologies that transformed industries from healthcare to agriculture and brought national recognition to Sri Lanka. But his impact doesn't stop in the lab. As a senior lecturer and through platforms like Niniti.com and his popular YouTube channel Science with Ruchira, he makes science accessible to all. He's a voice of inspiration, simplifying complex concepts and sparking curiosity in minds across generations, from school children to seasoned professionals. He is a mentor, a trailblazer, and a true believer in the power of science to serve society. His journey embodies the spirit of discovery and service. Ladies and gentlemen, now with great pride and anticipation, we open our doors to the brilliant mind, the mentor, and the visionary, Dr. Ruchira Wijesena.
All right, ladies and gentlemen, thank you very much for the kind introduction. I've been invited to so many sessions like this, but I guess I must commend I must commend the hard work students have put in to make a very beautiful, very thought-provoking type of a introduction. It's very nice. First, I must really thank you for the effort taken. And secondly, of course, I must also thank all the organizers for inviting me for this particular session. It's very, very important subject area. But I heard from one of your organizing committee members that you're going to start your work on IoT and related projects, and we are trying to educate, particularly the first year students who are going to embark on this particular journey, especially on the development, technical developments, new projects with IoT. So I think this is a very, very good initiative. And I think today my focus is going to be particularly on, not going to be on IoT in general, but how we design things in engineering. So what are the principles of design? What are the steps that we can take to make better product, better designs, and even we shall delve into some of the concepts in that may be useful in in final application. So these are going to be the themes of the talk today. I have a little slide deck that I wish to open up that it might aid me during the presentation. Just let me see if I can share this. Okay. Perfect. Yes. As I explained, this is going to be a talk that's going to primarily discuss on some of the design elements, not particularly on IoT, but we'll delve into some of the basic concepts, the primary, the very basics of it. But then this is going to be more of a design thinking and principles of design type of a discussion. Okay, so first, let me introduce myself just to put a context to the talk. My name is Ruchira Wijesena. In fact, I'm attached to this beautiful institute, Institute of Technology, University of Moratuwa, and I've been working there for like three years now. But before that, I worked at Sri Lanka Institute of Nanotechnology. I worked there more than 10 years. Sri Lanka Institute of Nanotechnology is an institute that is dedicated to the to sciences and also technology development, particularly in the advanced research area, especially nanotechnology, advanced technologies, advanced applications of nanotechnology related application area. So I worked there for more than 10 years. And in some of my projects, I had the opportunity to work closely with teams, closely with some of the IoT technologies. So the teams in some of the project groups, we had experts in IoT. I had an opportunity to learn a lot. And inherently in some of these projects, we had to go through very streamlined, very well optimized designing strategy. So I had experience for more than, I would say, directly that type of topics, maybe 7, 8 years of experience in some of these projects. Perhaps today in this talk, I'll try to share some of the insights that I gathered through the years in design some of these projects. Yeah, I'm a teacher right now. I'm an academic. I'm a lecturer. I teach, and on and off, I sometimes in sessions like this, I tend to, share what I have gathered through my experiences that I have gathered through the years with the general public. And I am fortunate to work with multiple companies, both public as well as private sector, in some of these, initiatives. And it was very insightful. Experience that I'm humbled that I had this opportunity to work with companies so that in terms of application, in terms of a design, I had a very I'm fortunate to have a wider cross section in many different areas. Okay, so let me start my discussion with principles of design. Okay, we will delve into IoT and IoT concepts, but first I think to have a good understanding of what we are going to uh, discuss and to lay a foundation, I think this is the best place to start. So as I understood, so most of you will be embarking on your own technical projects in time to come. And what's been right now, these sessions are trying to lay the foundation, help you, assist you, supplement you with some of the critical knowledge that is required to get you started. My dear students, so when we start with a project, especially technical projects, one of the things, the usual requirement is that there's a challenge that you'll be asked to solve a particular problem. So when you are asked to solve a problem, there's a set of requirements that you need to fulfill. Okay, so that's one of the basics, one of the most, in these type of projects, one of the basic requirements is that there's a problem that needs to be solved. What does it mean? So solving a problem means there are set of requirements that you need to fulfill. Not 100% sometimes, but you have to solve them in a level that it satisfies a particular level of particular level of you have to meet a particular level of satisfaction for individual requirements. So that is one of the key things when it's come to a key pillar, I would say, a key dimension of a project that you will be embarking in the near future. So that's that. Also, Remember, when you're asked to solve a problem, you do not have the liberty to use almost every resources that you can, the world is known. There are always limitations, a frame in which you have to solve this problem. You can do, these frames can be very different. Uh, Cost can be a frame, a boundary. You don't have millions of rupees of funding to solve a problem. You have a certain budget. Okay, so that can be a constraint or a limitation. Then there are certain technological limitations. You might not have access to some of the technologies. You may be asked to solve a problem with with technologies that you may have access to, easy access to. So that is also a constraint. On the other hand, there can also be constraints in terms of knowledge. You may not, obviously, there are so many technologies, so many, so many, approaches out there. You might not even know. So knowledge also become a constraint. So then, okay, so we have the problem. Then you have constraints, boundaries in which you have to solve the problem. Then finally, you'll be also evaluated for your outcome. Outcome, in your case, in many of the situation, is a type of a prototype or proof of concept. Now, proof of concept also has to demonstrate at least some of the, now we laid out initially, there are some critical requirements you need to fulfill. At least in proof of concept level, you must demonstrate that at least some of these requirements are, at least to the level of satisfaction, is met. Not 100%, but certain degree of fulfillment of this requirement is necessary, particularly in your level. So remember, Bhutana, when it's come to technical projects, there are these three pillars, three dimensions that you will need to juggle through. Okay. Now, so it is not easy. It takes a practice. It takes a lot of practice. It takes a lot of trial and error. It takes a lot of reflecting. Usually, Mudala, when we approach a design problem like this or a project like this, a very good initial starting point to balance all these three requirements. What are the requirements? The problem, the boundaries, and also outcomes. To balance these three points, a good design, a good design would always help you a lot. A very good design will always help you, put you into the front seat, push you, help you in terms of, managing all these three. Project means, Mutala, basically that executing a project means really you identify the problem, you define your boundaries, and then you manage your outcome. So how do you manage these three cycles? Really is what good project execution is. To do this, Vidal, as I said previously, a good design would always help you. And now let's look at, therefore, it's very, very important that you understand the key requirements or what we call principles of design. If you can delve into the principles of design early on and get those principles right, it will help you immensely in your project journey. Okay, so let's look into it. Let's look into that in detail. Good. See, okay, now I heard most of you here are engineering students, and here we have some IT students also, which of course, if you take I mean, IT industry is a project-based industry. So I'm taking a very nice or relevant example that might resonate with many of your students. Let's take a classical example. Now you are see. Now superimpose yourself into this person who's in this picture. There's a person in this picture. You can clearly see. He's sitting, standing on a ridge, a stone or a rock ridge. It's a steep. Apparently, it's a very steep edge, and he's looking at surrounding mountain. Apparently, suppose this person want to create a bridge connecting the the ridge he's standing on and also the other mountain he's looking at. Wants to make a bridge in between. Now, Putala, what I want you to ask, okay, now you get into his shoes and try to reflect. Try to reflect. What may be the critical thing, the most important things? Suppose that you are this engineer. Let's say he's an engineer. He's asked to make a bridge connecting this ridge and the mountain he's looking at. What are the key components of these projects? What are the key things he has to think about? He has to really focus on in getting this project done. Very classical engineering problem. Hmm? What are the three things? Now I want you to reflect. Get into his boots, reflect what may be the critical, come up with three at least, come up with three critical things that you may need to consider deeply in executing this project. For an example, three things you should consider. For an example, okay. Now, so when you ask this type of a question from many of engineering students, this is not the first time I pose this question to a set of engineering students. So I get very regular and very uniform type of answers, very predictable answers. So one of the things that that comes up very frequently is the cost. Cost is the most paramount thing they need to consider. Then, of course, I get the answer, the technology. Technology is something that he needs to answer. Then, of course, I get labor, how to get the labor requirement, the budget requirement, and various things like that. So what I want to say is now most of the time people when the first thing that comes to people's mind when they ask to perform and execute a project like this, the cost. See, if you want to connect two ridges, if you want to do it in the most economical way, I mean, look at this. I mean, this is the easiest way to do it, right? You just get a set of timber, connect them in a way, and just toss it across. Might be the most easiest, the most economical thing that you can do. But we ask the question. I mean, does it? I mean, it's obvious, right? It's not going to work. Shibutala, there are more important things, especially when if you're looking in the viewpoint of an engineer. There are so many important elements that may even come. Cost is a very important element, no doubt, but there are more important elements that you need to consider when you execute a project. I mean, it's also see one of the okay. See, um, it's also not this. You can so many see I have see this is not the I have in my career I have come up with so many different student projects. I had a chance to review them in various forums. When you ask a student or set of students to solve a particular type of problem, so one of the very common way of solving them is that this particular strategy. You throw a bucket of spaghetti on the wall and see what sticks. That's also very common. So you, you, what you do is minister. I'm not saying you guys, but then a very common strategy. Some of the students try to solve problem is that they somehow they know a little bit of something and they throw that on a wall and see what really sticks. Okay, that's probably the way. So that means that whatever the so with their existing knowledge that they have done little things, and based on that only they want to solve the problem, which is also not good strategy. So this gives you a very important message, very important message. Before we even try to even think about how to solve something, you must understand two important things. I mean, just because you can get something done, I mean, in the surface, doesn't really mean that you have really solved the problem. You have executed the project well. Number one. Number two, when you execute a project, always remember that there's something more that you need to deliver. Something there's a see, projects are, in fact, in essence, is a capacity, they are capacity building projects. See, projects are always capacity building operations. They are capacity building enterprises. Projects means that you need to learn. That means you have to come up with a little bit of more, more extra things. Some things that you need to learn things and you need to use them and you need to master them and apply them. So remember, projects, whether it be IoT, whether it be chemistry, material science, sociology, information technology, whatever it may be, remember, superficially solving something doesn't really mean that you have achieved anything. Number one. Number two is that you should always be aware whether you are using this strategy. You throw some spaghetti on the wall and see what sticks. No, no. Two very important things, especially for students when we try to execute these projects. When we clear out these two things, let's look at how to really solve a problem. Now, if you want to make a bridge, let's look at some of the bad examples. This is not a good example. See, this is not a good example of a bridge because you can see very little clearance exists in between this train and this bridge. Very little clearance. Which, I mean, what does it mean? Look at this. You are connecting two bridges, and apparently at the when they are meeting, there's a huge mismatch problem. Once again, you are trying to connect two bridges, and there's a huge mismatch in between. Some of these pictures are, in fact, real. Okay. So one of the very important things, I'm taking example of a bridge because it can resonate with many different fields and students, engineering and IT and any general field. See, when you perform, when you try to solve a problem with a project, remember, functionality is the most important element you must always keep in your mind. Functionality. Functionality comes above everything else. Everything else. You must, in your project, somehow fulfill the requirements to the level that at least there's some benefit. So we are not saying 100% fulfillment. You won't be in practical projects, you won't be able to achieve everything that needs to be achieved to the 100%. No, to the level that it satisfies the basic requirement. Functionality is a key important principle of design. Okay. design should align closely with the needs and the requirements. It should fulfill the requirements to the uh, at least to the level that satisfy the stakeholders. Number one. Look at this. This is an actual bridge. Now, suppose a bridge like this, if you're taking suppose you're taking a bridge like this, traveling up and down, I'm pretty sure that especially if you're coming down, you have to hold your breath. Uh, like something like this. Now, these are, in fact, some of these bridges were, in fact, proposed bridges. Uh, Something like this. Very extravagant designs. Very extravagant designs. See, Pudala, another very important aspect when it's come to, making projects. Simplicity is a very important virtue when we want to conduct projects. See, I have seen so many projects, especially from students, just because there are components available. They want to make it seemingly more complex. They think that simply because they have added more components, more logic, more functionality, that makes their project even more beautiful. See, for an engineer, that is not the philosophy you must abide by. A better philosophy is that we get rid of all the functionality. I mean, get rid of whatever uh, we typically call cut off the fat. Make the project lean as possible. When you make something simpler, the cost always goes down. It makes sense to people. It's much easier to market. It solves the problem more efficiently. I mean, I remember back in my days when Apple introduced iPod. Uh, Before that, we had all these cassette players, big Sony cassette type players, big like this. So many buttons that you can push on, sometimes very confusing. But iPod, if you have seen at least, I mean, just try it. It was a small device that you can play music. It had a very simple interface and a controller. Nothing else. Even when you look at this, it was even those days, even it was even difficult to understand how does it work with just a little button. Very simple, but it took the whole world. I remember back in my day, my first iPod I had, um, very, see, the simplicity always rewards you in the journey. Simplicity is a principle of design. Look at these bridges. What is the problem that you see? Obviously, you can see, look at this. This is, in fact, this is also, in fact, a real picture, real bridge that was built. It's one of the, uh, um, very famous bridges. Uh, this one also. So, what are the problems with these bridges? What are the problems with these bridges? Obviously, these bridges were, although they've been built, this was, in fact, this was also a proposed design. I think in, can't exactly remember where, but this was also proposed design. So you have one major bridge that is going across, and there was another shopping complex. Some set of engineers, in fact, proposed to connect these two, the bridge and the shopping complex with a suspension bridge like this without any support. Imagine the span of this bridge is over 100 meters. Imagine, would a person be brave enough to go across this bridge? You have water looking down. I mean, it must be very windy at this height. Given it's a suspension bridge, it must be swinging here and there all the time. See the problem. Uh, these problems, you can see some of these bridges, they have this problem. The problem with these bridges, they are not user-centric. When you design a product, when you design a project, you must design that project around the users. This is called user-centric design. User-centric design. As the user is in the center. We have to consider the needs and the preferences, the age, and various other factors related to our users to make more intuitive and user-friendly and efficient designs. That is called user-centric design. It's a very important component. එහෙනම් දැන් අපි දෙකක් කිව්වා තුනක් කිව්වා. So the functionality is a key requirement. Simplicity is a key requirement. And user-centric design. It has to build around whatever you do, it has to build around the user. Very important. Now look at this. Let's look at another one. Look at this is also a bridge. What are the problems associated with this bridge? What are the problems? You can clearly see. This is also a very well-known bridge. This has an angle over 15 degrees, if I am not mistaken. I prepared this like some time back. 15 degrees. Imagine you're coming down. You are, even without acceleration, your vehicle will speed up. So what are the problem with these bridges? These are not good designs. Nonetheless, built somewhere. So you see, safety is a principle of design. You must always try to minimize the risk associated with the project. There are always risks. There may be physical risks. There may also be virtual risks. Sometimes if you are involving user data, user profiles, and sensitive information, there may be virtual risk as well. There may be physical risks. If your project involved electricity, mechanical components, moving components, radiation and other chemical, if they are used, there may be considerations that you must always try to build around. Consideration you must always consider while you implement your project, execute your project. Then look at this. Now, this bridge is not, in terms of design, is not bad. But then, of course, this bridge was built in a pristine ecosystem where there were a lot of endemic plants. The engineers, for some reason, have decided to completely wipe off whatever the plant, the growth in the area, completely eradicate all the plants, and even the whatever the animals were chased out, and they build these oil pumps that goes through the whole thing. This is also a very nice design. This bridge was built in an area where there were traditional fishermen. And after building this bridge, because of the sand deposit, the current tend to change. The sand obviously with the sea currents, sand get displaced and get deposited in various areas. Now, because of the clearance issues, the traditional fishermen couldn't really go through couldn't use the whatever the bypass areas they were dedicated. They had to go through all the way, just to go in between, had to go through all the way and come back. So what are the problems? Now, this is also very nice bridge, a good example. This bridge was built in an area where there was a native, there were native people they had some sort of a ferry service supporting that native community. Because of the bridge, they had a lot of economic problems because this native group of people who are native at this area had lot of economic hardship because their trade and their main source of income affected. Uh, so what are the problems with these things? So the problems that you see in some of these design is the sustainability. So if your product or design is going to make problems in terms of ecology and in terms of culture, and also if it makes social problems, and if increase in consumption, it increase more waste being disposed to the the world. All these are problematic. So the one of the key aspect, therefore, another aspect that you must always consider is what we call sustainability. Now, my dear students, these are the principles of design. Principles of design. So when you try to implement your project, you must always consider, when you design a project, you must always consider these key areas, these 5 pillars, and you must take every attempt to integrate this concept or this requirement into your project. So, I mean, this is how you make a better engineering design. You use your principles. Principles are the very basic things. What are the key things? Functionality, simplicity, user-centric design, safety, and sustainability. There are a few more, but these are at least in your level. You must always try to implement at least some elements of these in your designs. Uh, User-centric design, especially, has even more consideration. I mean, it's very important that you pay really good attention to user-centric design. In Latin word, we call this hominum centricus. Hominum means human, centricus mean around. The greatest gift an engineer can give to mankind is that you design a project for around a human being that is in need of um, in need of that product or service. So only an engineer can do. I mean, engineer in the sense that I'm not a professional engineer, but anybody who would use technology to solve problems in that classification. If we use that terms to classify engineers, then it's a very nice place to be in the world. You're solving practical problems of the people. So when you do that, make sure that you always around, build your product around users. Now, a very good example to this is camera. How camera evolved through the years. Give a very nice description to what hominum centricus is. Earliest days of camera was just what we call a whole camera. So you have a very big box where an artist can go in, and there's a small hole that you can open up, which will open it into a landscape. And obviously, because of the properties of the light, you get this inverted image being projected on the one side of the wall, and the artist would take his time to sketch the key areas, key demarcations of this painting, which he would later build on in his studio. This was the earliest camera. But then camera could change. You implemented what we call light screen, photosensitive screen, and that even got focusing element later. Uh, the early cameras hadn't had any term of focusing, but it was, you can see, to operate a camera, you need at least, I mean, army of people. See how many you had those days. But that got changed with portable camera with various designs people had. So this is what we call film camera came in. The first camera picture that ever taken. Hmm. So different focusing lengths, interchangeable screens came in. The camera, the lighting setups came in. Then the real camera came in. This at least I have seen. Real camera came in. Then digital camera came in. You can see the evolve. Look at how even the shape of the camera evolved. Even shape of the camera evolved. Look at this. Now modern camera, you can see this is how it is. Okay. You can see even the ergonomics, how you even hold your camera has been optimized. Now here we don't have any rule. It's just a matter of focusing and selecting the mode. Sometimes some camera even select the mode by itself now these days. Now even there are smaller cameras that you implement, more powerful cameras you implement in your mobile phone. See, so now previously we talked about user-centric design is a very key importance of engineering design. Within engineering user-centric design, there are 5 components again. So what they are? Usability. Now early cameras, they were not really usable. You need skilled people to operate them. Now anybody can take a photograph. You don't need much of skill. Accessibility. A skilled artisan was required to take a picture those days. Now a technician. Now anybody can take it. Use experience. It's a small device. Now you look at a mobile phone, very small design, very easy to handle, not heavy. Design is, explanatory in many cases. Ergonomics, integration. Now in modern cameras, you not only take a photo, you can even geotag it. So these are a little bit more additional components, principles of human-centric design. So in your project, I told you there are 5 requirements. Then remember, when you think about user-centric design, try to implement some of these things as well. A very good usable user experience based on an ergonomic design for your project is very helpful. Okay. So these were particularly from the principles of design front. Now I think we can go into a little bit of our main theme today. Okay, then after that we will have a quick discussion. See, IoT or Internet of Things been a very popular, and in fact, if you take Industry 4.0, IoT is one of the key fronts, pioneering fronts in Industry 4.0. Internet of Things simply means we have things, sensors, things. It can be light sensors, it can be temperature sensor, it can be humidity sensors, mechanical sensors that detect some mechanical movements, anything. So many things are magnetic field sensors, pH electrochemical sensors, light level sensors, spectrophotometers, all these things. Something that generates electrical output. Electrical sometimes it can be analog output, sometimes even digital output. Doesn't really matter. Some form of electrical output is a sensor in this case. Uh, there are even um, uh, biochemical sensors. Okay, for that matter, that sometimes project a generate a chemical signal. These are also there. So things are being connected using some form of connectivity. You might have Wi-Fi, Bluetooth, 4G, LoRa, even long distance radio communication protocol, LoRa, very popular now. I have a project going right now with LoRa. So uh, those days, you see, instruments had sensors. That is nothing new. I mean, that is like 40, 30 years ago. Instrument, the oven had a temperature sensor. It could turn it on and off through a control system. That is nothing new. The importance of Internet of Things is that the information, the data could be sent through some form of connectivity into a what we call cloud, or it can be cloud or a edge device where it will look at this data, sometime process this data, or at least transmit this data, do some form of additional activity on this data, uh, even apply a logic, and that get to some form of user device. And even uh, this logic, the application of logic might, it may maybe send another signal back to the devices, back to the sensors or to the devices to operate them in a different way. So what Internet of Things mean that you have connectivity. Sometimes in the case, sometimes you can connect multiple devices that are physically separated in many different places. That will feed data to the cloud or the edge processing device that give you more real-time information, that gives you more information about what's happening. So you can take smart decisions with data. Okay, so Internet of Things is primarily is the if you take four pillars: things, connectivity, data processing, and some form of user interface. In the user interface, sometimes not necessary. You might have some. I have seen some IoT functionalities even without user interface. But these are the components. Uh, mm, so Internet of Things have is now becoming, it's emerging, or at least now we wouldn't even say emerging, it's already there as a very good way of, very popular way of solving real world problems. When we started out in our university, we had nothing like this, no Internet of Things, nothing. So we had to design projects that solve problems then and there. Now your generation have this special ability where, okay, we also had some devices, but I mean, just to be fair, but then in your generation, you have this ability to, I mean, make much more smart decisions in solving some of the real world problems with Internet of Things. This connectivity, fast connectivity and data um, transfer between the devices and even computation, especially in some cloud devices that offer now very high computational ability that helps you, solve harder problems with data more efficiently and more rapid manner. Very powerful. There are so many examples. Some of the examples I have personally worked with are smart agricultural IoT systems, where in a typical, especially if you take protected agriculture, you see in protected agriculture, you have you need to have controlled environments. You have plants that are growing, especially plants need ample amount of light, ample amount of nutrients, ample amount of water to get a, good growth, okay, commendable growth. But typically, how this is supplement? This is typically in a conventional way, a farmer would go in and feel some of these things. He might have a thermometer, he might have a soil sensor, he might even take a bit of soil from the pots and feel it whether the soil moisture is good enough. He might he may even, I mean, sometimes he doesn't even have any idea about the level of nutrients. No, nothing. He has to only collect sample and send it to a lab to get that measurement. Now, so that's the conventional method. Now, with IoT devices, there are IoT systems that can you implement these sensors in the protected house, which will sense the humidity, which will sense the temperature, the moisture level, nutrient level sometimes, and based on that, there's a standard or a better or a required level of condition that you need to maintain. Suppose if the soil moisture goes below a certain point, it will automatically activate a water pump that feeds the plants, or give a message to the farmer saying that this is what it is. It can log data, so the farmers can take much more better design. So it might consider even, okay, suppose the temperature goes up very rapidly in certain seasons of the year, the farmer may have better chance, I mean, he might have uh, data to consider some other project being implemented on top of the protected house to solve that. So like that, you get a much more smarter system right away when you connect this. Okay. You have data also, you can analyze the data, and the farmers can even look at the yield patterns, how much of uh, the produce been how these individual parameters correlate with the produce, or the yield is that the typical term yield. All this data will make a much more smarter agriculture system altogether. Smart homes. Suppose when you go in, when you sleep, the temperature has to be maintained. When you are sleeping, you have no sense whether, I mean, whether you just need to be comfortable. You can have temperature sensors, humidity sensors, thermal sensors, sensing your comfortable level, calculating comfortable level, and adjusting whatever requirement. Suppose when you go out a smart home, you go into a room, you typically need to turn on the switch, right, during the night time to get the to light the environment. But then you can have IoT sensors, IoT sensors that detects your movement, your entry, and turn on the light. These are very basic things. Okay, it measure things. Suppose there's an intruder coming into the house, might alert the occupants. The lighting conditions may be adjusted. Your devices, your TV, your radio, and even tablets may be synchronized. Weather forecasts have been projected. All these things. Imagine the possibilities. So many problems can be solved. So many opportunities can be given with these type of systems. Elderly care. Now, in many countries, I mean, we have increase of elderly population, and we don't have young populations now to take care of the elderly. Can we have simple device that they might wear that takes all the important you know vital biosignals like heart rate, pulse rate, sugar level, whatsoever, their movement, and if something goes, uh, I mean, not right, or it's suppose elder person, you know, I mean, for some reason, fall down to the floor, fall down, and he's not responding. He will detect the band or something that we might wear, will detect that, send that information quickly to the internet, alert third-party agents, maybe emergency units that will take care of that. Now, in a typical environment or a typical setup, you may need to, assign a caregiver, a caretaker for each elderly person. Now we are solving that big problem. We can, at least some elements of it, can you solve with technology, IoT. So many applications to this. Uh, Real-time data is a very important aspect of IoT systems. Efficiency, you can think about the elderly care system. Instead of appointing individual caregivers, you can have a caregiver monitoring number of elderly people at a given time. You can make things more user-centered. See, if you take agricultural IoT system, different farmers will grow different, fruits, and their preferences may vary. Their fertigation patterns may vary. So you can with the IoT system, you can give that flexibility with not without very rapid scaling of the cost. Hmm? And you may, because of because of the sensors, you get the data. You can make more smarter decisions. Scalability. You can these systems are usually modular. You can connect some of these components together and make much more scaled prototypes, or at least the products with it. So these are some of the things that you can actively think about. These may be your strengths when you implement a project. So think about these things when you try to implement a project, especially in your research. Okay, so there are so many aspects to this. Now, let me give some examples. In any university, if you take Moratuwa University, when you after 12:15, when the morning sessions, lecture sessions are over, we always see huge queues being formed for the canteen. We have multiple canteens. In certain canteens, we have much longer line. In certain canteens, we have a smaller queue. Can we make, uh, if we can make an IoT system which will measure and predict the length of the queue, and maybe update that information in a mobile app or something like that, then the students might look at that and see these are the areas that you have much larger queues. These are the canteens you have smaller queues. Then why don't we go there? You won't be late for the lectures. Very simple. These are common problems we see. Finding a quiet place in your campus. You can integrate noise level sensors in certain areas. So I'm just giving some example, thinking out loud. A good place to stand. Okay, you might know, okay, now the library. So I went to what is the general thing? You go to the library and see the library is full of people. You turn back and come. You go to the canteen and you see the canteen line is so long. So you go to the other canteen that's also there. You go to the other canteen, the huge queues. Yeah. So when what you do is you go here and there, your time will be finished. Even for the management, it's helpful. So you can see, they can clearly see, okay, then this at lunchtime, here huge queue. So why don't we manage some of the timetable so that the students can go in and take a little bit early lunch or a late lunch or something like that. See, you can instantly make a smart system. Garbage management or waste management, in which areas you have much more waste. Okay, some universities have shuttle system, or two has a shuttle system. These are common things. When the shuttle is coming, if the student can know where the shuttle is, very easy, right? It would be so helpful. Now, I know some students, they formed WhatsApp group and so on. They share the life location. But think about that. It's not a, that's in a way as also an IoT solution, because your mobile device has sensor that upload that information to the cloud and get shared with a group of people. But what about the people who will be taking that shuttle for the first time? No accessibility. Accessibility is a user-centric design, a principle, right? So there are so many things that you can think about. So one of the very powerful frameworks that you can take to solve some of these problems is called design thinking process. In design thinking, so what you do is we go through four key processes. That is, we call empathize, define, ideate, prototype, and test. Okay, so these are very important steps that you can take. So this design thinking process revolves around three main pillars. We call it understand, explore, and materials. Understand means, I hope you can remember, initially at the first time, the very first, when I started this lecture, I told you there's a there are three pillars in executing a project. You have some of the requirements that you need to fulfill. Understand means that you understand what those requirements are. Clearly, sometimes we think we understand those, but no. Explore means you look at that boundary. What are the boundaries in which I can solve this problem? What may be the solutions that I can take within this boundary to solve this problem? Materialize means that outcome part, exactly what I explained previously. In design thinking, we take what we call double diamond method. These are important things. I'm giving you a brief. I must emphasize on the fact that these are, I mean, typically this whole thing, engineering design is a complete module, all right, for engineering students even. I mean, I'm trying to boil it down to 1.5 hours. Okay, so I'm just giving you some of the keywords. You can explore more and learn more about these methods. What we call double diamond method. Empathize means that we have what we call divergence. That you look at a problem, you think about various aspects of that whatever the requirement. So that you have what we call divergent thinking. You think divergently about a problem. Define means when you understand a problem, you must define. I said previously, you must come up with some set of requirements that you need to fulfill. Requirement 1, requirement 2, requirement 3, requirement 4. So you look at a problem. So initially you'll be given a problem. You must empathize in the sense that you must try to understand that problem, then define that problem into one or key requirements that you need to fulfill as the second step. Then what we call ideate. Ideate means that to solve to uh, to fulfill those requirements, then you need to think again in a divergent manner. You think about all the various ways that you can, different ways that you can solve that question problem. This is also divergent thinking. That's why we call ideate. Prototype means you make something, a simple prototype that might fulfill that is with the aim of fulfilling your defined objectives. And finally, you have testing, multiple testing. So remember, as I previously told you, this is the innovation process or designing process where you try to understand, explore, and materialize. So within understand, you have both empathize and define components. In explore, you have ideate and prototype components, and materialize in prototype and testing components. So you must understand what are the divergent components and what are the convergent components in a given system. Empathize means, as I previously told you, who are the stakeholders of a problem that you're going to reflect. Now, for an example, if you take the campus shuttle bus, or let's say canteen, uh, waiting list or canteen waiting queue problem, who are the stakeholders? Students are stakeholders. The canteen management is a stakeholder. And you must understand what various parameters. You must get into shoes of these individual people, the shoes of the student who's waiting in line to get his food, and the shoes of the shop owner who wants to sell something, sell food to the students, the shoe of the university administration. All these different components you must understand. So when you understand their individual requirements, sometimes through interviews, sometimes through surveys, sometimes through, you know, let's take, interviews and observation. You understand the pain points, the requirements of individual people that you have to define. Now, define means a very specific. You have to give a specific value. So now, after interviewing these students, you might come up with, okay, the students will not like to stay in a queue more than 3 minutes. If you come with a very specific term like this, you have defined your problem. If you have any, after you interviewing a shop owner, if he might come up and say, okay, now I prepare food for 500 students. By whatever the IoT system that you are going to implement, if the number of students that are going to come to my canteen is going to be lower, suppose it's going to be 300, that I am in a loss. No, I can't do that. So you have to think about issues. So your IoT system somehow manage the whole operation in such a way that you get 500 people somehow good to that canteen also. So like that, you interview. So that is empathize mean you try to understand the requirement of individual people, then you define it with some specific requirements. You can create user personalities, like very define their roles, user user profile skill. So but you can define those things so to understand and solve the problems better. Ideate means how you going to solve this problem, whether you are going to use mobile app. Now, one way to solve this problem is that you can make a mobile app and ask students to rate the number or give ask students to tell if you are waiting in a queue. You can say, I am waiting in a queue, huge uh, line in this particular, they can say, give a response. So the students give that response that will get populated into that's one way of solving. Or else you can have a sensor, right? You can have some kind of a PIR sensor or some optical or a camera sensor that detects the length of the queue and that get updated. That's also one way of selling that. Or else you can have a dedicated person in the canteen, always uploading, I mean, this information. I like that. So, there are different ways of solving. It doesn't need to be IoT. It's different ways of solving this problem. So you must always explore all these things. That's why I told you, ideate is a divergent process. So that is that step. Ideation means you try to come up with all the crazy ways of solving this problem. You must always try to brainstorm different ideas and come up with one better. Then what we call prototype. You must, sometime, usually, Putala, when your ideated products will not always work. I mean, usually they will never work. You must do various prototypes. You have to do it again and again and again. You make a prototype, you test it, you make a prototype and test it, and you get user responses. You can measure its response with respect to you can measure their you can measure their effectiveness against some of the requirements that you set initially. Based on that, you can improve your prototype. Improved prototype ultimately get closer to the final product that you want to build. So that's what we do. So prototype testing, so rapid prototyping and recurrent testing, rapid testing. You test prototype, test prototype, test prototype. When you do that, when you do multiple times, then you get a much better version. See, this is what it is. If you want to make a rubber doll that will soothe a baby during the bath time, you first start with the users. Who are the users? What is the age gap of this? What is the age of typical the kid? You might be interested of a rubber ducky. The age of the parents. Where would typically a parent take this routine? What type of room? What type of soap they may be using? What type of water level? Imagine these things you need to then you define, okay, to soothe a baby, what type of who's required, what type of animal would suit. Ah, you can make a fish, no? You can make a instead of a duck, you can make a fish. The fish will, I mean, just simply go down. But instead, suppose if we can make a rubber ducky which is floating on the water, that would make it more interesting, right? You can also make a rattle to soothe a baby, but with the water, rattle wouldn't really give a nice sound. That's a problem. But instead, you can see. So when you think about, okay, suppose there is a define, you define the problem. You need something to soothe the baby. Then you come up with some various ideas. Ideate. Different, you can design any number of different ducks, right? Ducks with long head, ducks with huge, you know, the body and, different shapes, whatever. Cute ones, and, like that. Then you can prototype. The first prototype might never work, will never work. You prototype, you testing, you perform this multiple times, and finally you come up with final implementable prototype. See, that's what the whole process is. This you can implement these type of things in any place. I mean, this design thinking is a very well known, very respected way of designing, not only in IT, but IoT, but in many different areas. Okay, so you can make better products, better designs, neat products, usable products with this type of philosophy. All these are very important path you can take. So remember, final section of my presentation is that, see, there are problems with already resolved problems. You may have problems that apparently be solved. No, there are chairs, right? There are chairs like this. But then when these chairs exist, people still wanted to make chairs like this. Why? You may have incremental improvements over the products. I mean, Minister, I mean, so some people tell, do not reinvent the wheel. No, there's no such thing like that. People have reinvented the wheel over and over and over again. We have better wheels for various different applications. So, like that, Putana, remember, even in some of the projects that you'll be executing, you may take up a problem that is already seemingly solved. No, but there are maybe some niche areas. Sometimes for niche users may have some specific problems. If you take anything, if you take something as simple as a pen, there may be problems for some specific people. You can solve those. People think now I mean, there are the wheel. They say never, don't. I mean, don't. I mean, don't. We should not reinvent the wheel. No. See, this is the wheel that has been designed for the Mars rover that only use some form of a metal fabric. Yeah, so that's reinvention. Different wheels can be, see, even now, wheels are been defined, experimented, different wheels. Now, this is a wheel that can go not only on the rolling direction, but in the other two crosswise directions also. See, all that these are remember. So very important, it's very important to have a creative spark, think creatively. When you do that, Putala, you will see a very interesting ways of solving problem. We have spoons and we have forks. Why can't we have something in between? Forks. Hmm? People tend to carry water uh, of miles and miles long journeys. Why wouldn't we simply, without carrying it, why can't we simply make a roller or a device where you can load the water, fill the water up, and then simply you push it. like you would roll typical this, this toy, something that you can pull. So you are not then, you are carrying the water, you are just pulling it, which is much more efficient. So there are always better ways of solving this problem. So IoT is a very nice way, very nice technology that you can adapt to solve some of these practical problems, pressing problems the society has. Remember, you take the principles of design and principles of human-centric design in and try to implement these projects through design thinking uh, framework. That will definitely help you a lot in solving some of these problems or the projects, executing these projects in an excellent level. Okay, so this talk is intended to give you some basics of this, project methodology. Uh, this will only provide you some guideline. It's your duty to explore more about individual. These are, I mean, as I told you, this is a total module. Uh, 15, 15 lecture module, engineering design. I delivered it like, yeah, 1 hour and 15 minutes. Okay. What I will do is I'll encourage you to go through these concepts and try to understand this even more and practically use it. It's a very powerful technique, Buddha. Okay. So with that, I shall conclude my delivery. If you have any questions, you can ask me. I now would like to give the stage to the moderators. Thank you very much.
Thank you very much, sir, for the insightful and thought-provoking session. Now we open the floor for the Q&A session. This is your chance to directly engage with Dr. Ruchira. If you have any questions, please feel free to drop them in the chat.
Yeah, so I can share the presentation. I will probably share it with the student who've been in contact with me, and yeah, that's possible. A book recommendation. Well, I suppose, uh, yeah, there are better design. But engineering design is I mean, it's a very common field. But then, what I would recommend for you for undergraduate is that you may instead of going through a book, you may resolve for some of the online resources, maybe YouTube or something like that, because it gives you much more interactive. I mean, there may be examples you will find in YouTube that some documentaries how they show you how to sort of solve their problem practically. They will show you how they are you there may be documentaries you will find. I have seen some show how people, these engineers, use this method to solve a design problem. So that's more practical. So you can use that. Um, uh, okay, in design thinking, rapid prototyping is important. Yes. What are some easy ways to prototype IoT solutions? There are three different ways to. I mean, generally there are so many. Uh, what are the easy ways to prototype IoT solution? IoT or otherwise, uh, so there are three main methods of validating your prototype. First validation in the laboratory scale validation, that the designers themselves will evaluate for the critical function. Critical function is the most critical functionality that you need to fulfill. That's number one. Number two is that you will take the prototype to relevant environment briefly to the relevant environment, and let it operate and see what are the difficulties that you foresee, that you will encounter during the process. This is the number two. So we take the prototyping in the relevant environment briefly. Then you can do is, so with that you will see a lot of problems. You have to solve them through testing and development. And then you again take it to the permanently to the relevant environment. You keep it for some time, maybe 1 week, 2 week, and you will see the functionality in long run. So these are the three easy ways. I mean, this is no easy way of doing this. You have to do it in the real way. Uh, you evaluate for the critical function, then you in the relevant environment you evaluate for the critical function and peripheral functions, and you keep it for long duration to implement it in long run. Designing need creativity. What kind of habits can we apply to our daily routine to our imagination, creative skills? Okay, good question. Uh, I will show you one thing that you can do to really increase your creativity. You can do this test. A very simple test. This is uh, if you can do this. If you can imagine 20 different creative ways of using a brick. This is not only brick. You can think about from a book, from a stone, from a light bulb, from a piece of wood. So like that, if you think, you will find that initially, when you think about this, what are the uses of a brick? What you can do with a brick? You will find first five, six, maybe first 10 things easily. It will come to your mind very easily. But when you develop your list, you will see with time, with the number of responses, it will become difficult. You have to push yourself to come up with a creative answer. So that is a good, nice way of pushing yourself to be much more creative. This is a proven method to really help you out in designing process. I mean, that's a good activity you can do in your okay, fashion design students in faculty. Yeah, when there are for fashion design also, there are a lot of IoT applications. Okay, for an instance, suppose depending on your movement, your speed, you can have IoT device that you can have a sensor that measures your acceleration and movement. Depending on that, you can put some light bulbs or LEDs or light strips that get illuminated in a particular way. Very nice. You can do all that. There are many IoT applications. You can wearable devices. It's possible. Uh, mm, um, yeah, LoRa is a very helpful and a protocol, especially when it's come to uh, long distance communication. It's quite energy efficient. Now, when we started out, the LoRa components were quite expensive. Now it's not the case. Okay, so LoRa is a very good thing that you can experience. It's also reliable, very tend to be energy efficient also. You can try and implement these components, and I mean the protocols are very well known now. You can obviously use GitHub and various other platforms to get it validated and initially get it run. How do we come up with a practical problem within our scope when we have some projects to design a project? See, the very easy way of doing that is basically you think about some of the pain points you are already having. suppose you have your campus bus. You always come and wait for 15 minutes. Sometimes you miss the vehicle or the shuttle. Sometimes you come early to the bus stop and you have to wait. These are pain points. Sometimes these we take them as granted. We take them granted. We don't think about these things. Just think about some of the difficulties, pain points we always see. Always we wait in a queue, right? That we take it granted. We don't think that we can solve that problem. So that's, I think, that probably the best way to approach this. There are many other methods, but then practical problems within our scope, think about some of the pain points you are already having. Simple as that. Can you spark an idea of how we can implement these concepts too? Yeah, so you have to really take the design thinking approach. I encourage you to study it further and take up, you know, learn a little bit more and maybe use in YouTube. You will definitely find how the design thinking approach, how some problems that really, I mean, how they will show how they some of the projects are executed, like documentaries. Look at those. This will be helpful. They will show you in practice. I just gave you the framework. Now. They will give you examples how this is done in real life. How to design a chair, how to design an IoT device, how to design a sensor or a wristwatch, something like that. Design app with IoT. Or that you will find these documentaries online, particularly in YouTube. I would okay. See, Aputala, my battery is dying apparently. So I'll be continuing. Mm, now let me see. Uh, yeah, 37 තියෙනවා ඉන්න බලන්න. ඔව්, පේන්නේම නැතුව. හරි හරි. කුත් නොකර මේක. හරි. Okay. Yeah, my opinion, having reliability issue is highest priority. But having reliable, you're having reliability issues when using ESP32 family MCUs for everybody. See, ESP32 it's a very now it's very common. I mean, obviously, you can as you have really identified, there are various issues related to that. Sometimes due to some of the, especially there are three funds. There are power problems in terms of power consumption and power reliability and power management problems. We have problems in the ESP32. Then, of course, I mean, there were compatibility issues also with some modules. And these are with the new drivers, they are mostly sorted out. And then, of course, you have with extended implementation. When you keep you make a device and you keep it for a long time, you have problems, of course, implementing or the operations that sometimes not even possible to trace. So these are the three main problems we have with the ESP32 and similar devices. You see, ESP32 microcontrollers, if you are talking about these little devices that they are intended to be used as prototyping machines, really. They are particularly being used as prototyping machines. So for your main prototypes, after you complete your prototype, then when you scale it up, when you scale it up and you get it done, when you demonstrate the functionality in a high fidelity level, then ideally you would take the core components, the most essential components of ESG and go and design a different PCB. Yeah, that's the whole idea. I mean, in real life, in real product design, that's where you'll stop. Okay, you'll not definitely use. I mean, there I have seen people using ASP devices as they are in projects in commercial level also. But then the typical part is that. Um, so I would advise in your level, Sala, in your level, use. I mean, you will find various ways of addressing some of these issues. Um, uh, I mean, go through that. Have a very strong foundation in some of these things, understanding some of the common issues related to some of the devices that you're using would be really helpful when you. So that's what you call the simplicity element. It's very important when we start off a project like this. Are all this an engineering fisherman? How to prepare for all this is an engineering freshman. The tips and I see this is your drill puta. This is what it is. Now you are you are taking. I mean, you have to do it, and uh, yeah, you have to do this. When you do these projects, you will learn. That's the whole idea of studentship, right? There's no easy way of doing that. You have to you groom yourself while you are doing this. Any tips in the sense? I advise you to do a good job at your with your projects. That's the only tip I can give you. Yeah. So it's a learning experience always. I mean, these projects you will fail definitely in many different approach. When you try projects initially, you will fail, and you fail, you learn, you fail, you learn, and that's what it is. I mean, there's no easy way of doing these things. You just need to learn, and you will get better at doing those things in future. That's what it is. Yeah. How does edge computing help improve the experience of using IoT devices? Yes, edge computing typically give you a faster response. It also helps you in implementing some of the basic suppose if some basic filtering or basic mathematical or logic applications to be implemented on the incoming data, it can help you in doing that. It's also reduce the computational time. uh, I mean, if it requires multiple layers of computation. So these are some of the basic things. I think you can look it up specifically for your application. You might design what type of infrastructure you'll require. Yeah, so that is a very specific answer. I just gave you some broad um, these things. So given that, see, I'm not my expert area also. Mama, these are just by I'm answering all these things based on my experience as a member and also as a principal scientist in some of these projects. So they were expert engineers who were, I mean, they were really doing IoT and also all these type of things. I was just a member of the group, sometimes as the supervisor. Only through that I'm talking, yeah. So you can go to your expert lecturers or supervisors and get further uh, insights. So IoT job these days, yes, IoT is I mean, in terms of product development, IoT there are so many applications, especially for an engineer. IoT is here to stay. Any device is now connected, and your ability to design and develop design and develop projects, products with IoT is essential almost. I mean, it's an essential skill, I think. So I think I let me reframe the question. Any inside IoT job opportunities these days? So if you're going to really get into product development, IoT is, I mean, not, I mean, without IoT implementation or at least some insight, um, um, some experience, I don't think you will be competitive. Yeah. Could you suggest some IoT platform, the tools that students can use quickly, prototype and test their ideas using design thinking? Yeah. So these you can IoT platforms. I mean, very common platforms are available. You can take ESP systems and Arduino systems. They are the very, I would say, the most basic place to start. Yeah. I think that's what where most of the students would start their work. How can claim ownership of our ideas? Mm, yeah. So idea when you okay, you see idea has no value. People have everyone have if all of us have ideas about various things, right? So idea itself, their ideas are so common that they do not intrinsically have value. An idea that has been tested, prototypes, optimized, and may converted into a product will have an idea. And for that, obviously, you can claim the ownership through uh, intellectual property methods. You can either, the most common one is you can patent it if it's novel and if it's not obvious to the common man or a man of basic skill. And if it's not a mathematical formulation or any other sorts of creative work, then you can apply for National Intellectual Property Organization, NIPO in Sri Lanka, and take up this thing. So what you need to do is just need to fill an application with some details, and that they will process that and give you some give you ownership to the project. The future category option computer systems engineer, where the time can how can do projects with basic knowledge. Are there platforms for that? Um, mm, yeah, yeah. Okay, Putal. See now, it's a very broad question. What are the future career opportunities in computer systems engineering? And at the same time, how can we do projects with basic knowledge? Are there any platforms for that? Okay, let's take the first question, future career opportunities in computer systems engineering. Now, as you already understand, this is becoming very competitive. Now, on top of that, AI is automating lot of requirement, and in terms of the uh, yeah, um, we can see 10, 15 years down the line, most of these mundane functions that require computer system engineering will be automated with AI. That's what we see. Okay. So, uh, mm, however, Bhutala, remember always in any of these works, there's a human element. Human element. In any of these projects, there is human element. A person, you see, AI wouldn't be able to empathize a project, a user. Not easily, at least. That's a human, very human. You have to think what the people who may be uh, lining up in a canteen queue, what sort of a thing that they will be feeling. Get into their booths. It's a human thing. Negotiation is a human thing. Creativity is a more human thing. So I think so what you need to demonstrate in future for your future recruitability is that Zara, really you must demonstrate people, your recruiters in future. You must not the qualification. You must get into all these clubs or whatever. Show that you have demonstrated your ability to getting things done in various societies, working with you people, executing projects. I have some vision මට මේ මොකක් හරි විෂන් එකක් තියෙන මිනිස්සෙක් මට ඒ විෂන් එක ඉම්ප්ලිමන්ට් කරන්න පුළුවන් කියන එක තේරෙන විදිහ ඔයගලන්ගේ රෙසුමේ එක ඇතුලේ පෙන්නන්න ඕන පුතාලා. That's more than ever. That's what I always tell my students also. And you go get into all these societies, get some projects done, hackathon දෙක තුනකට යන්න කරන්න ඒව කරලා ගන්න සාතික හරි මොනවා හරි දින දෙයක් ගන්න. Work on all these things. Be better at this. You must be always ready to embrace lifelong learning. Be ready for that. If you have that sort of caliber, එතකොට හිතන්න දැන් ඔයාගේ CV එකත් එක්ක ඔයා දානවා. හැකතොන් 10ක් විතර ඔයා කරලා තියෙන ප්‍රොජෙක්ට්ස් 5ක් 6ක් ඔයා කරලා ඉම්ප්ලිමන්ට් කරලා තියෙනවා. ඒවට සාතිකක් තියෙනවා, බෝඩ්සුත් තියෙනවා. මේක යමක් කරගන්නත් පුළුවන්. මිනිස්සුන්ට ඉන්ටර්විව් එකට ගියාම හොඳට කතා කරගන්නත් පුළුවන්. හොඳ පර්සනැලිටි එකක් තියෙනවා. All that you will be still recruitable. I know students like that. දැන් ඔයගොල්ලන්ට කියන internship එක හොයාගන්න අමාරුයි කියලා in certain areas. No, I know I know students Moratuwa. I mean, they get all involved from early on. පළවෙනි අවුරුද්දේ ඉඳලා දේවල් වලට කැප වෙලා projects වලට committee වල meeting වල society වල ඒගොල්ලෝ වැඩ කරලා ඒගොල්ලෝ demonstrate කරලා meeting එකට ගිහිල්ලා යා ඒක දන්නවා ඒතර pitch කරගන්න. I mean, you just first you are through. Yes, what it is. Same time, how can we do project with basic knowledge? You are not here to do projects with basic knowledge. You are here to learn. Learn advanced method of doing things. Do not get with more basic things. Basic things මුලින්ම පටන් ගන්න අඩියක් තියන්න YouTube වල මොනවා හරි පාවිච්චි කරන්න documents හරි කරලා පොඩි project එකක් කරලා implement කරලා concept එක ඔළුවට දාගෙන ඒක උඩින් implement කර උස්සරහට යන්න. It's the only way of doing that. The rapid integration of AI and IoT, how do we foresee design thinking evolving over the next 5 years? See, design thinking is a framework that has always been there. I mean, there's no other way of designing things. AI will help some of the things automate in this process. But design thinking, humans have to do it. Yeah. Rapid integration of IoT will help you. දැන් හිතන්නකෝ දැන් ඩකි කෙනෙක් මට මම කියනවා මට ඩකි කෙනෙක් දැන් මම හිතලා අයිඩියේට් කරනවා ළමයාව සූට් කරන්න මට ඕනේ ඩකි කෙනෙක් තමයි පාවෙන කහ පාට ඩකි කෙනෙක් මට කියන කියලා මම AI වලට දුන්නාම මේ ආටිස්ට් කෙනෙක් එක ඒ ඩකි ඔයා ඉමේජින් කරන ඩකි අඳිනවට වඩා ඔයා ප්‍රොම්ප්ට් එක දුන්නාම AI එකෙන් හදලා දෙයි ඩකීස්ලා 50ක් 60ක් එක පෙන්නයි. අන්න ඒ වගේ ඔටෝමේට් වෙනවා. එතකොට ලේසි වෙනවා, ඔප්ටිමයිස් වෙනවා. But then you have to make that call. I need a ducky to soothe a baby. That part still remain human. At least for I think next 5 years that will still remain human, and for some time it will remain human. First year with less prior experience, what are the IoT paths they can take good practice and benefit the categories? Take baby steps. Go to YouTube, get some basics, some පොඩි ඔය තියෙන YouTube එකේ තියලා කරලා තියෙන IoT project එක එහෙම්මම කරලා බලන්නකෝ. ඒක කරගෙන යනකොට ඕක ඔයගොල්ලෝ ඒ වයර් ටික අටවල මේව කරන්න ගත්තාම ඕක පළවෙනිට වෙන්නේ නැහැ. ඒකෙන් ඔයගොල්ලෝ ගොඩාක් ඉගෙන ගන්නවා. ඊට පස්සේ දෙවෙනි එකට යන්න. ඊට පස්සේ ඊළඟ එකට යන්න. එහෙම තමයි මේක කරන්න තියෙන basic skill එකට. Yeah. So when you get, when you practice it, you be better at it. Data security and privacy using IoT. Your opinion, yeah. So this, good question. See, data privacy, data security is a very important concern that will fall under safety. If you want to design the engineering design like a component safety gaining principles of design. So data is a very important aspect because you get some sensitive information that gets shared across various servers, and you must always make sure if the sensitivity, depending on the sensitivity of the data, you take appropriate actions to secure people. I mean, make sure that who can access this information, who can see this information, all that. I mean, at your level, just be mindful about some of the sensitive information at your level. But then there are various, when you go up in the in your profession, you will be dealing with much more social and practical problems where you will need to deal with policymakers, various granting bodies, and regulation authorities in getting these things done. Okay, just to at your level, just get a basic understanding what it is, what are the basic policy requirements and the ethics of dealing with data. What industries benefit from most of the IoT technology right now? I think if I talk about generally I would say telecommunication industry definitely leads the game. Telecommunication. Then I would say medical industry has lost so much of application. Then, of course, we have the facilities management and the building infrastructure, construction, not construction even, the facilities management sector have many applications. So I think that's there. Facilities including transportation, all this, yeah. This is not talking about, I'm not talking about defense and, all that things. I'm pretty sure they have a very good share. I mean, in fact, I mean, tell me one single area that is not touched with by IoT. Out of that, yeah. So telecommunication industry and the medical industry quite big. I am designing LMS. I wanted to enhance the accessibility. Actually, struggling. I would like to hear the insight from yourself. It will help a lot. Thank you. Learning management system. I guess you must do like this. See, I can give. මට ඉතින් තියෙන්නේ මේ lectures upload කරන්න ඒව ටිකනේ. ඕගොල්ලෝ තමයි මේකේ තියෙන ඇත්තම ගැටලුව දන්නේ. You must do a survey. Do a survey or at least do some interviews. With then you will understand what are the problems. Do a survey. You reflect yourself. What are the problems with the LMS? What are the problems you are going to solve? කියන එක. මට නම් තියෙන්නේ ළමයින්ට හොඳට LMS එක මට ඕනේ ළමයින්ව assess කරන්න. ඔයගොල්ලෝ copy කරනවනේ මේ LMS එකේ දැන් මම MCQ එකක් හරි මොකක් හරි Moodle එකේ දාපු ගමන් I don't know whether you have Moodle. ළමයින්ට ඒක දැම්මාන් පස්සේ Moodle එකේ assessment එකක් දෙන්න MCQ දැම්මාම ඒගොල්ලෝ share කරගෙන කරනවා. I would like really මට තියෙනවා නම් Moodle එකක් මොකක් හරි LMS එකක්. So some way that students cannot share their whatever. එහෙම ඒ ස්පොට් එකේ දෙන්න පුළුවන් ඒ වගේ නම් මම නම් අර කැමති. That's the teachers saying, but then think about yourself. I would say some interviews and then probably some survey would help you in planning out your work. I would like to create solution for the day of the reform child, but with each time till you come up with the idea, it's a solution already exists. Do you then stop doing it? No. Uttara, as I said, you can still reinvent the wheel. Suppose you have a problem, you see there's an existing solution for that. If there's an existing solution, there are also be problems that system is not solving. දැන් ඔයාට තියෙන අදහසක් තියෙනවා ඔයාට තියෙනවා අන්න ඒකට solution එක IoT solution ඇවිල්ලා තියෙනවා. එතකොට ඒකෙන් discourage වෙන්න එපා. ඒක study කරලා බලන්න. ඒකේ ඉන්න users ලට සමහර හැම user එක වගේ නෙමෙයිනේ. elderly users ලා ඉන්නවා. male female කියලා difference එකක් තියෙනවා. අධ්‍යාපනයේ තියන අය ඉන්නවා, අධ්‍යාපනයේ නැති අය ඉන්නවා. කලබලෙන් වැඩ කරන අය ඉන්නවා. නේද? ඒව තියෙනවනේ sectors. You can think about one of these niches. Niche area එකක් කරන්න මොකද්ද ඒගොල්ලන්ට තියෙන specific ප්‍රශ්නයක් ඔයලා ඒකට උත්තරයක් දෙන්න බලන්න. That's probably a way to go ahead. Future career opportunities in computer system මම මේක කියලා දුන්නා. You mentioned limitation as this. What your opinion to overcome this limitation when reaching the advanced technology IT compared to other countries? Limitation කියන්නේ project limitation. The project එක දෙන්නාම ඕගොල්ලන්ට cost මේ රුපියල් 10000 ඔයගොල්ලෝ ප්‍රොජෙක්ට් එකට අපේ කැම්පස් එකෙන් දෙන්නේ මේ 10000 ඇතුලේ කරන දෙයක් කරගන්න කියලා කියන්න පුළුවන්. That's also limitation. දැන් ඕගොල්ලෝ ගාව තියෙන දැන් ඕගොල්ලන්ට ගන්න පුළුවන් මයික්‍රෝ කන්ට්‍රෝලර්ස් වල limit එකක් තියෙනවනේ USB එකක් හරි මේකක් මොනවා හරි එහෙමනේ. That's also the organized technology access එක. ඕගොල්ලන් තියෙන software. ඒ වගේ limitations තියෙනවා. So you must, you know, නේද? ඒ වගේ එක එක limited policy requirements. දැන් ඕගොල්ලන් සමහර some data you cannot ask නේද? You cannot ask, you cannot keep gender data, then age data, all that. Even if you, I mean, you have to have some policy, some at least some policy of sharing this information and storing this information. So these are the limitations. You must, it's very easy now. If you see a problem, a limitation, you just go to AI, use some AI tool. You can say, these are the problems that I have, limitations I have, my project. What are the ways of overcoming this task? You get some insights from there. AI is a very good tool for you. අපිට අපේ කාලේ මොකක්වත් තිබුණේ නැහැ. අපි හොයලා හොයලා කල්පනා කරලා කරන්න ඕනේ. You can do that, you know. Yeah, I think I answered for the future career computer system. So when we need to stop the Q&A, yeah, actually I think we can stop that now. So I got problem with especially in home assistant, ESP home add-on. Yeah, I'm not sure about how to solve that problem. But I know good matter. I'm not sure this Wi-Fi problem, ESP home assistant. Yeah, so just GitHub is a good place to start. You know, solving these problems. Yeah. ඉතින් මෙහෙමයි මේ දෙකේ ගැටලු තියෙනවා මේවා ඉතින් ඕගලන්ට කරලා කරලාම තමයි ඉතින් මේවා සෝට් කරගන්න වෙන්නේ පුතා. I know sometimes you get ඕගලන්ගේ එක පාර්ට් එකක් තමයි මේක ඇවිල්ලා එක පාරම ඔයගොල්ලෝ බලනකොට මේක වෙන්නේ හරි ෆ්‍රස්ට්‍රේටිං. මේ තියෙන කෝඩ් එක ගැහුවොත් වැඩ කරන්නේ ඒක බලලා තමයි ඒක එකපාර සෝට් වෙන්නේ නෑ පුතා. ඉතින් ඒක බලලා වයර් ටික ආයෙ අමුණලා බලන්න ඕනේ. All that you have to do. That's part of the learning. Unfortunately or fortunately. Yeah, so that's what it is. Other than learning is you are here to learn, no? So learning is you have to go through a process. Reflect, process, problem, all that is part of learning. Don't get frustrated. You know, every time you ask a question, you are a little bit better than before. Have that positive mindset එක තමයි හැමදේම පුතා. මට නම් බෑ මේක මට කියලා එහෙම එකක් නෑ නෑ මේක මට පුළුවන් මේක හදාගෙන ඉස්සරහට යන් කියන මයින්ඩ්සෙට් එකට එන්න පුතා. ඒක හිතලාම එන්න. ඒතර ආවම පස්සේ හරි ඒක මේ ඇත්තටම ඒක කාගෙන යන්න පුළුවන් මේක. නැත්තම් හොඳ ඉංජිනේර කෙනෙක් වෙන්න අමාරුයි ඇත්තට. You have to have that particular set of mindset. හොඳ thick skin එක හොඳට ඝනකම් හමක් තියෙන්න ඕනේ. හොඳට කමියුනිකේට් කරන්න පුළුවන් වෙන්න ඕනේ. මිනිස්සුන්ව කන්වින්ස් කරන්න පුළුවන් වෙන්න ඕනේ. හොඳට දැනුම තියෙන්න ඕනේ, ටෙක්නිකල් දැනුම. To be a good engineer, you need all these skills. Okay. All right. So I think we have, yeah. So almost all the questions I answered. Yes. All right. So, okay. We shall then, okay. So to the coordinator then.
We have had some wonderful questions and insightful responses. Thank you, Dr. Ruchira, and thank you to all participants. As we are coming to the end of our allocated time, we will wrap up the Q&A segment now. As we come to the end of the session, we would first like to take a moment to express our gratitude to our distinguished speaker. As a token of appreciation, we are delighted to present a token of appreciation to Dr. Ruchira Wijesena for sharing his valuable insights with us today.
This is nice, huh? Yeah. Very nice. Hmm. Yeah, I'm humble. Thank you very much for that.
Thank you very much, Dr. Ruchira. As we come to the end of this session, I would now like to invite Janita Maya Dunna, the chairperson of Electroverse 2025, to deliver the vote of thanks.
Good evening, everyone. As we come to the end of today's session on design thinking with IoT, I take this moment to extend our heartfelt gratitude. First, a sincere thank you to all our distinguished guest speaker, Dr. Ruchira N. Wijesena, for sharing valuable insights and inspiring us with your knowledge and experience. Our thanks also go to the IEEE Student Branch Chapter of SLIIT, the organizing committee, and all our honorary members for their support in making this event possible. And most importantly, a big thank you to all our participants for your time, energy, and active participation. Your involvement truly made this session meaningful. Thank you and have a wonderful day.
Before we end this interesting session, we would love to capture this moment with a group photo together with our guest speaker. So may I kindly request everyone to please turn on your cameras and join us for a quick picture. Thank you, everyone. At this point, Dr. Ruchira may need to leave the meeting. So, on behalf of the IEEE PACE, the student branch chapter of SLIIT, we sincerely appreciate his valuable time, his inspiring session, and the knowledge he shared with us today. We are truly grateful, sir. Also, we truly value your thoughts. A QR code will be now shared on the screen. We kindly encourage all participants to take a minute to fill it out, as your feedback will help us improve and bring you even better events in the future. On behalf of the IEEE PACE student branch of SLIIT, I would like to thank each and every one of you for joining us today. We hope this session has inspired you to explore new possibilities with IoT. Have a wonderful evening ahead and see you at our upcoming sessions. Thank you and good night.